Okay, so in this video, I'm going to teach you how to solve systems of equations involving two variables using the substitution method. Okay, so as we know, there are two most commonly used methods in solving equations, and that one is substitution and the other is what we call the elimination method. So this video will focus on the substitution method. Let us take, for example, the equation negative 7x minus 2y equals negative 13, and x minus 2y equals 11. So how do we know if the substitution method is an efficient way of solving systems of equations involving two variables? For me, what I do is I check the coefficients of x and y. And when you see a single variable with a coefficient of 1, then the substitution method could be an efficient way in solving the systems of equations. So by inspection, we have negative 7x, negative 2y, 1x, and negative 2y. So because the x in the second equation has a coefficient 1, then it seems to be that the substitution method will be an efficient way of solving this equation or system of equations. Note, however, that the elimination is also an efficient way in solving this. It's just that what I'm saying is, when you decide for the substitution method, you check whether one of the variables has a coefficient equals 1, and we have it here in this problem. So since we have x minus 2y equals 11, with x containing a coefficient 1, we focus on this equation and solve the equation by isolating the x. So this becomes x is, when you add 2y on both sides, you have x plus 0, which is just x, equals 11 plus 2y. Your teacher might have said you transpose the 2y or minus 2y and becomes plus 2y, but essentially we are adding both sides by 2y. So once you have isolated the x, then you will be substituting this value of x on the first equation or one of the equations, because we use the second. So this x here that you see will be replaced by 11 plus 2y. That is why it is called the substitution method, because we are substituting an expression to one of the variables in the other equation. So doing that, we have negative 7, and then for the x, we now supply it by 11 plus 2y minus 2y equals negative 13. And as you can see, the equation was reduced into a single variable. Hence, we will be able to find the value of one of the variables, and in this case, it's y. So to continue, distribute properly. This is negative 77 minus 14y, copy minus 2y equals negative 13. And then this becomes negative 77, negative 14y or minus 14y, and a minus 2y will become minus 16y equals negative 13. Isolating the y, we have to add 77 on both sides. So the left side becomes minus 16y or negative 16y equals 77 minus 13 or negative 13 plus 77 equals 64. And then if we divide both sides by negative 16, negative 16 will cancel. 64 divided by negative 16 or over negative 16 is negative 4. Therefore, the value of x, the value of y rather, is equal to negative 4. And once you have the one of the variables, then all you have to do is to go back here remember, we isolated the x and we have x equals 11 plus 2y. You will be reusing this in looking for the value of x. So if that is x equals 11 plus 2y, so if x is equal to 11 plus 2y, and we already know that y is negative 4, then we have 11 plus 2 times negative 4 means 11. 2 times negative 4 is negative 8, so that's the same as 11 minus 8, which is equal to 3. So the value of x is equal to 3. Therefore, the solution for this system of equations is 3 for the x and y is negative 4, or you could say x is 3 and y is equal to negative 4. So either way will be accepted. Okay? Now, just to add an optional step to determine whether the solutions are correct, we will be checking by substituting the values on the original equation. So to check, so this is for checking, we have negative 7 times the value of x, which is 3, minus 2 times the value of y, negative 4. We need to ensure that it becomes negative 13. So we have negative 7 times 3 is negative 21. Negative 2 times negative 4 is positive 8. When you add the 2, it becomes negative 13. So it means x and y are the correct values for the first equation. But for the second equation, we have x minus 2y. So that's x is 3 minus 2 times negative 4. We are expecting the value to be 11. And when we check, we have 3 minus 2 times negative 4 means plus 8. 3 plus 8 is equal to 11. So indeed, the values of x and y are correct. Okay, so that's an optional step for you to be confident of your answers. So you have to check, or you may want to check it by substituting the values on the original equations. Okay, so just to summarize, when you apply the substitution method, it is very important to check whether it is efficient by checking is for a single variable with a coefficient equals 1. If that is the case, then the substitution will be an efficient way in solving the systems of equations. Otherwise, you use the other method, which is called the elimination method. And we have seen here from the example that x has a coefficient of y, 1, so we use the substitution method. And when you work on the equation with that variable, you will get this equation, and then you substitute it on the first. Okay, and from there you solve for the y until you get the value of the y, and once you have one of the values, which is y, go back to the original equation and substitute, and in that way you'll be able to get the value of x, which is equal to 3. Again, an optional way to check whether your answers are correct is to substitute the values in the original equation. Okay, so this is just one of the many equations that you will encounter. I think this is the most basic one. So try to make videos containing systems of equations in which maybe you have a fraction or you have a decimal value or something that is not very obvious to know whether you use substitution or the elimination method. Okay, but for now, so these are the basic ideas on how to solve systems of equations using the substitution method. Okay, that's it.